Okay, so here, before starting this, we are looking for the confidence interval, right? Before starting the confidence interval, I want to know what am I using, the z-scores or the t-scores, and why. All right, what do you think? Since n, all right, there are a couple of things that indicative here. So first of all, they give you n greater than 100. This is going to give you a z table, right? The second thing, they told you sigma is known. The population, do you see it? So this is going to be, again, z table. All right? So we have both conditions. Sigma is known and n is greater than 100. So this is going to be the z table. This is what you're supposed to figure out first. Now, they are asking about the 95% confidence interval. You have a formula you can use it right away. So the confidence interval, which is the mean, is between x bar minus sigma divided by radical n times z alpha over 2. And the other one is x bar plus sigma divided by radical n times z alpha over 2. So the problem is, what is z alpha over 2? Okay. I am hoping that everybody had the small table of the confidence interval. Do you know what I'm talking about? No? All right. I don't really remember, but let's say 7, maybe. I'm talking about this table. Every time you have the confidence interval with the table, you don't have to go all over the place and looking for the table or the z value on the big table. You should have this small table, and this simplifies your life. You got it? So I am done because I know this one is given to me is 100,000 plus this one is given to is 20,000. This one is 100, and this one is going to be 1.96. 95%. You got it? I got all the components over there. So the only thing I gotta do is plug it in and let the calculator do the work. So this is gonna be 100,000 minus 20,000 divided by radical 100 and times 1.96. And the other one is gonna be 100,000 plus 20,000. I hope somebody's doing this. Times 1.96. And that's it with A. All right, so give me the numbers whenever you get it. B. B is asking you about how large a sample should be taken if the mean score for the all teenager boys is to be estimated within the 95% confidence interval within 25 points. So the 25 points, that's going to be the E, all right, that's the error. And they are asking about the N. And the N is, you have a formula for the N. Which is sigma times z alpha over 2 divided by the error and squared. All right? And again, you have all the components over here, so you just have to plug it in. Remember, they told you 95%. So this is going to be a 20,000 times 1.96 divided by 25, and you square this. Remember, for this one, you have to round up all the time. If you don't get exact number, you round it up. Anybody get the first one?
96,000.
Like that. 96080. Okay. And the other one? Say again.
102,900.
Thank you so much. We good? All right, so the other one, you're gonna be the other one is a big number. 2,458,624. Okay, again, I remember the formulas. I'm not expecting you to remember the formulas. You remember that, right? Now, could you please go to your formula sheet and identify where are the two formulas?
The first one was in the Z conference principle for meetings.
What section?
Chapter 7.
7, very good. Chapter 7, 7.1, right? Okay, and we are using the formula that it is under the Z table, right? There is another formula under the T table. And over there, you can find the N too, right? There is next to it, there is an N value. Please see it on your formula sheet, guys. Really, that's what is all about this class. Okay, so we're done with 16. Let's move on. All right, so 17 is giving you how many timing in there? There are 10, right? 10 values, 10 players. So what about 10 players? The N is less than 30, right? So what happened whenever less than 30? What table you are using? Less than 30, that's going to give you the T table right away. And sigma, they never gave you sigma. Sigma is unknown. Do you remember the other one, the previous one? They told you sigma is equal to 20,000. The population standard deviation is 20,000. Okay, so what we're going to do here, I just remember this. Leave your phone. I think the other class is empty, the front one. Okay, determine the 95% confidence interval again. All right, so we are doing exactly the same thing. So I need somebody to, no, I don't even need anybody. I don't need, because usually that's what they do on the exams. Do you notice here that although they give you the data, they still give you the values on the bottom. So there is no need to plug it into the calculator and do it. All right. So now this became really easy because I'm looking for the confidence interval 95%. So this is going to be the mean is between X value bar, that's the formula, right? Minus, I'm not using sigma, I'm using S divided by radical N times T alpha over 2, right? And over here, it's going to be X bar plus S divided by radical N T alpha over 2. And honestly, for this one, I don't have any option but to use the T table. So I don't have like a small table like the previous one, right? So do I know the X bar? Yes, I know the X bar. The X bar is going to be 9.48. Do I know the S? Yes, that's going to be 2.14. Divided by radical N, radical 10, all right? And the T, that's the only thing that I don't know, right? So I am missing the T from both sides, right? How can I get the T? So in order to determine the T, I need degree of freedom, which is n minus 1, and this is going to be 10 minus 1, which is 9. I need the alpha, and the alpha is, since this one is confidence interval, the alpha is 0.05. Well, the formula for this, whatever remaining, right? So the formula for this one is going to be 1 minus alpha divided by 2. Sorry, 1 minus the confidence interval divided by 2. 1 minus the confidence interval divided by 2. It means 1 minus 0.95 divided by 2. If I have 95%, what is missing? 5%, correct? So this is going to be 0.05 divided by 2, and that's going to be 250, right? Do I need that? No, I don't really need that. Maybe. Which one? 10 minus 1? Are you here? Here? Confidence interval. CI. So I think it's better to understand it this way. This is my confidence interval, 95%. Whatever remaining here is 0.0250. All right? Give me a minute. I need to grab the table. Okay, so one tail is 0.25, right? A degree of freedom, 9. Or you can go all the way to the bottom with this table and you can see the 95% over here, right? As well, that's possibility. So what is the degree 9? This is degree 9, one tail here, and that's going to be 0.025. the number you're going to be looking for is 2.262. We got it? And that's it. That's what you're going to do. Here you're going to put 2.262 and here 2.262. You do the calculation and that's going to be your confidence interval. That's A. B, find the point. Okay, this is kind of tricky question. Find the best point estimate. Our the best point estimate. Ours is the X bar. X bar is going to be 9.48. You don't have really to do anything in here. C. All right, so a student is selected at random and had a mean of 5 minutes. Is it 5 minutes good or bad? In order to answer to this, I need A. So let me do the calculation since nobody want to participate here. All right, so 9.48 minus 2.14. Okay, the lowest part is 7.94. The upper side is 76.88. We good? So now they are asking you here for this one, you get X equals to 5. So where is 5 located at? Is it inside or outside? It's out of the range 7.95 and 76.89. I think I made a mistake here. It's not 76.89. Could you please double check? That's too big. Yeah, definitely 11. So this one is going to be 11.01. 11.01 is good, yeah. So the 5 is outside of that interval, and that interval is 95%. So definitely you are really far away, right? Is it odd? Of course it's odd. So what the meaning of this? The 95% is here. The lowest value is 7.95. And this value is located somewhere here. This probability there is very far away. All right? It does not happen so often. Okay, so this is question number 17, and is not, as you can see, is not that difficult. Number 18. All right, a sample of 38 students enrolled in a program that claimed to improve the scores of quantitative reasoning portion of the graduate record examination GRE, right? The participant take a mock GRE test before the program begins and gain again at the end of to ensure their improvement. All right, so what they are looking for the X bar. The X bar here, that's the difference between them. X bar is going to be 12. Assume standard deviation is going to be 55. That's population mean. All right, so sigma is known. There are 38 students. Sigma is known. What kind of table you're going to be using? Z table. All right, the two conditions are verified, so Z table. One of them is wrong, T table. Okay. Determine whether the program is effective at test made, hypothesis H0. This is your claim. The mean equals 0 versus the mean greater than 0, right? At the level of 0.01. Identify the type of distribution that should be used for this test. Is it Z-test or T-test? What we said? Z-test. Why? Because n equals to 38, greater than 30, and sigma equals to 55, which is known, right? Okay. Let's go to B. Compute the test statistic. So test statistic is Z statistic or test, right? This is going to be X bar minus the mean divided by sigma divided by radical n. Are you familiar with this, right? X bar is 12. What the mean? You see it over here? The mean is 0, correct? So minus 0 divided by sigma, which is 55, divided by radical 38. One 1.3449, 1.34. All right. C, compute the p-value. Now, before computing the p-value, you need to know whether it's a one tail versus two tails. What do you think? Is it one tail or two tails? One tail. Why? Because we have the hypothesis H1, this one, right? So if I do this, this is the normal distribution. Mean is greater than 0. 0 is here. Greater than 0, you're going to cut off here. And this is 1. I don't know where is 1.34, but anyway, so I don't really care about that. So this is my cutoffs from this side and this side. So what I care about 134. What's it going to be? The t-test. So 134 is, pretend I don't have this, right? Pretend I don't have the cutoffs. The 134 is the location z-test. This is going to be 1.34. The p-value is this one, the p-value. Do you understand, guys, why I needed to know one tail or two tails? I needed to know one tail versus two tails because if it is two tails, that p-value I have to multiply by 2, right and left. This is one tail, that means the totality of the p-value gonna go there. How can I get it? Again, I need my z table. Big tail or small tail? Small tail. All right, so I need to grab the z table again. All right, so 1.34, and we say is a small tail, so 1.3 and 4. 1.3 is 1.3 here, the 4 is over here. So this is gonna be my number. Everybody okay? 0901, right? And you're all set. P-value is gonna be 0904. Now, they could have gone with another conclusion. Do you accept or reject? So the question done here, right? Do you accept or reject the null hypothesis? So if you have the p-value, the statement is still the same. If the p-value less than the alpha value, the conclusion always reject. Otherwise, you're going to be the opposite. So what's the p-value? I have the p-value 0.0901. What the alpha value? 0.01, right? It is? Yes. All right. So if it is confusing for you guys to compare these two, give them, I think I'm wrong with the alpha, 001. Is it? 001. Yeah, it's fine. So if I am confused between these two values, give them the same number of digits after the decimal point. It means if I have 4 here, make them 4 over here. And you can see here 100 and 900. Which one greater? All right, this one greater. So if it is this one greater, what's going to be the conclusion? That's the opposite conclusion, by the way, right? What's going to be the conclusion? The opposite conclusion too. Do not reject. So here I didn't want to give you two formulas. I gave you only one formula. The other one would become the negation of this. You got it? So if I don't have the p-value less than alpha, then I do not reject. If the p-value is less than alpha, then I reject. So this is another question, right? This is D, for example. How do you use the p-value to make your conclusion? And if you reject it, you can go and make a phrase about the claim, right? Okay, next one. So you have a sample of 11 private colleges was 26,500. That's the tuition, right? Standard deviation is $6,000. So before continuing, what do you want to identify? Again, it's the same issue. T table versus Z table. You got it? And what you should be here? This is the same conclusion. Before starting any problem, you need to know whether I'm gonna be using the T table or the Z table. And why is it the Z table and why is it the T table?
So you have, in this sense, you have sigma, right? And that's like anything that has to be more than, I'm not mistaken.
Okay, do you see you're not reading sigma. Sigma, you're not identifying. Yes, I have a standard deviation, but they never said the population standard deviation. Did they say population? So it's not. So you don't have the sigma. That standard deviation is only for the 11 colleges. They even wrote 11 there. So 11, is it bigger than 30 or smaller than 30? Smaller. If smaller than 30, automatically you go to the T table. You understand? So here, 11 is less than 30. I go right away to the T table. And beside that, they are giving you the standard deviation, the 6,000, that the sample standard deviation of the 11 people. That's S, not sigma. All right, so I am definitely using the T table. I don't know if it is clear or not, guys. Okay. All right, you wish to test whether the mean tuition of private college is different. It's different than 31. So let's start. So A, they are asking you to say the hypothesis. They say different there. So the mean is different than 31,000. And since they say different, that's going to be H1. H0 is going to be the same. The mean equals to 31,000. This one is going to be the claim, right? So once I knew my claim, I can make a small chart and I can figure out this is the two tails. And this is going to be my Z critical. This is Z critical. I don't know yet what the values, but this is what's going to happen. I'm going to reject and accept according to these values, right? Do not reject here. And here reject A0 and reject A0. So I divide my plan in three positions, right? Three parts. Let's go to find the critical value, B. Oh, I'm sorry, guys. I say Z critical, that's T critical. Since I said the T table, right? All right, find the critical values. So what are the critical values? T critical. In order to find the T critical, what I need degree of freedom, which is n minus 1, and that's going to be 11 minus 1, which is 10. I need as well the alpha value. The alpha value is 0.05, and as you can see, there are two tails over there, right? We good? Now, once I get these two here, I need to go to my T table and get the values. Okay, what we said, 10 and the alpha 2 tails 005. All right, 10 is right here. And you look for two tails, 005, this one. $2.228. Are we okay? So I go back to my chart. The zero is over here. The one on the right is going to be 2.228 positive, and the one on the left is going to be minus 2.228. All right, are you following me, guys? Yes, any question? No? Done with that, compute the test value, see? All right, T stat. It can be X bar minus the mean divided by S divided by radical N, right? So X bar is going to be what they got for X bar? They got 26, right? 26,500. Thank you. They got 26,500, right? So this is going to be 26,500 minus 31,000. That's the mean. Divided by S, which is 6,000. Divided by radical. What the N, guys? 11, very good. All right, you need to plug in the calculator and figure out what is it. Yeah, I don't think I got the right one. I know. My calculation is getting me. It's hard to calculate with the phone. I think I got minus 2.487. All right, so where the minus 2.487 is gonna fall? So you're gonna fall here. What zone is that? Reject, right? So if you reject it, E, do you have enough evidence or not? We have evidence actually to support the claim, right? And if you want, you can say that here, what the claim is saying, right? So you copy exactly what the claim is saying. Do you see the green part? So you copy from here that the mean tuition and fee for private college is different from 31,000. You understand it? And that's basically it. That's 19. The mean fee or whatever it is. I know what the cent is. The mean tuition. Yeah. Okay, I hope this is clear. Yes. Next. Okay, my understanding here, there are 14 women and 17 men are selected. The women first, they are the one, and the men, they are the two indices. And they are collecting data, how many hours for, I mean, he or she has to watch television during the previous week, all right? So they are counting the number of hours, they're giving you the standard deviation, and they are giving you how many subjects in the study, right? So this is literally comparing two means, all right? But in comparing two means, we have two different comparing two means. We have comparing two means with independent and the other one dependent. And this case is the independent. All right, so if you are looking into chapter 9, I think, it should be independent. All right? Independent subjects. Now, state the hypothesis testing. So we gotta look for it. Use the level of 0.05 significance level to test the claim that the mean amount of time spent watching television by women is smaller than the mean amount of time spent watching television by men. In other words, what they are saying is the mu1 is less than mu2, right? However, the way that we did it before, we did it like this: mu1 minus mu2 less than 0. That's what you are looking for. All right? So for A, whenever you state your hypothesis, is mu1 minus mu2 less than 0. That's H1, of course. And H0 will be the same thing, mu1 minus mu2 equals to 0. So this is my hypothesis testing. Once I'm done with hypothesis testing again, the graph doesn't hurt. So less than 0 will be the left tail. All right. So this is my alpha, basically, which is equals to 0.05. And this is going to be my cutoff. It's going to be reject here. And from here, do not reject. Okay. Let's move on to B. B, find the critical value. So what will be the critical value? By the way, we are using T or Z again. T, why T? They never gave you the sigma. They gave you the S instead. So sigma is unknown. The second thing, look at the N, guys. The N is not going to be wrong. N is smaller than 30. You're going to be T table. All right. I think the N is the easiest one. So this is the T value. So I am looking for the T critical. The critical value I need to know, degree of freedom. So that's going to be the minimum value of N1 and N2. Minus 1. This is going to be the smallest value is 14 minus 1, which is 13, right? That's degree of freedom. And you need to know the alpha, which is 0.05. And you need to know one tail versus two tail. And this is one tail. And again, here I'm going to use the T table. We say 14 minus 1 is 13. So degree of freedom 13, over here 13. And 0.05, I believe so. 0.05, one tail. One tail here, 0.05 is going to be here. Is it this number? So 1771, right? So I believe so. I'm doubting, hold on, no, I'm wrong here. Although it is one tail, we counted in two tails. One 771. That's it, 1771. So the T here critical. The value is 1.771. However, since it is on the left side, it's going to be negative, right? I just want to double check this. I don't want to make a mistake. Yeah, it's good. All right, are we okay with the T critical? T critical out of the table, right? C, compute the value of the test value, right? So here the test value, since we are comparing two means, do you remember the formula, the ugly one? All right, the T stat here is going to be x1 bar minus x2 bar minus mu1 minus mu2 divided by the square root of s1 squared divided by n1 plus s2 squared divided by n2. All right. You need to locate it again. You need to know that I am comparing between two means. All right. So once you have this, be careful about this one because this is the problem. Some people, they see it on the formula and they don't know. This is 0. How did I know 0? Because that's my hypothesis, H0. Do you see it there? Mu1 minus mu2 is 0. So then, just you have to plug in the number that is provided to you. So this is going to be 12.5 minus 13.8 divided by the square root of S1, which is 3.9. Yeah, I froze up here. Whatever. Is paused. What is paused? Okay. So S1, what is S1 again? 3.9 Here's my pencil died. All right, 3.9 squared and divide by N1, which is 14, plus 5.2 squared divided by 17, right? And you just have to plug it into the calculator. Anybody's doing this? All right, so let's go to the solution and get the number from there. It's going to be 0.795. Minus 0.795, all right? Now, if I'm gonna go and plot it, where it gonna be? It gonna be somewhere there. What's it gonna be? Accept or reject? Do not reject, all right? So this is gonna be D, do not reject. And finally, E, summarize the result. So whenever you summarize the result, what's it gonna be? You did not reject. So are you having enough evidence or not? We do not have enough evidence to what? Oh, by the way, which one is the claim? This one, the claim, right? We do not have enough evidence to support the claim, right? And again, if you want to put that here and you put what the claim is, that the mean amount of time spent watching TV, blah, 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 blah. Okay, I hope this really helps.